Dear students, this session we are going to see revision on second order partial differential equations, right? First problem. Solve d square minus d dash minus 2d dash the whole square into z equal to 2x plus 3y plus e power 3x plus 4y. Okay, is the given partial differential equation. The auxiliary equation is found by replacing d by m and d dash by 1. Hence we get m square minus m minus 2 equal to 0. Now factorizing this, we get m equal to 2 or m equal to minus 1. Therefore the complementary function will be, we have two rules, so write two different functions, f1 and f2, right? We have two variables y, x, in between put plus 2 here. Similarly, in between these two, put minus 1 here. So we get complementary function is f1 y plus 2x plus f2 y minus x, right? Now we are going to find a particular integral. Okay. So here in RHS, in RHS we have 2x plus 3y plus e power 3x plus 4. We have three functions there. So we can write particular integral as 2x by d square minus 2d dash minus 2d dash square plus similarly 3y by d dash square minus d dash minus 2d dash square and e power 3x plus 4y by d square minus d dash minus 2d dash square. Okay, so we have three particular integrals pi1, pi2, pi3. Okay, now first consider pi1. Okay, so here 1 by d square minus d dash minus d dash square into 2s. So function here is algebraic function. If it is algebraic function, we are going to apply binomial formula, right? Okay, so take d square as common factor, right? Now we so here we have only 1d, so put 1d in the denominator. We have no d square here, so put d square in the denominator. So both cases minus is common, take minus is common here. Okay, now rearrange like this. So 2 is constant term, bring this side d square, that is 2 by d square. Okay, now bring this term to numerator. So in power it is 1. If you bring this to numerator, become minus 1. Right? Now we have 2d square into 1 minus some operators power minus 1 into algebraic function. Okay. Now we can apply binomial formula. Just like 1 minus x power minus 1. What is the formula? 1 plus x square and so on. Okay. Right? So here we have 2 by d square. Instead of x we have d dash by d plus 2d dash square d square. The operator here we have is x. Okay, right? Now apply binomial formula. What happened? 1 plus d dash by d plus d dash square by d square plus d dash by d plus d dash square d square whole square and so on up to x, right? Now see, the operator here is d dash. Okay, that means d dash represents differentiate with respect to y. But function here is x term. Okay, if we differentiate this with respect to y, become constant 0, right? So the end all the term becomes 0. So only 1 is left here. Therefore 1 into x become x. So we have x here. After simplification we get 2x by d square. 2x by d square, right? 1 by d square means integrate twice. Okay, integrate twice. 1 by d square means integrate twice. Only d square means differentiate twice. Okay, so if we integrate x one time, we get x square by 2. If we integrate again, we get x cube by 6. Cancelling 2, we get x cube by 3. Okay, this is particular integral 1. Now to find a particular integral 2, 1 by d square minus d dash minus 2d dash square into 3 1. Same thing here. Same thing here. Take d square as common. Again we have the same expansion. This time we have function y. So d dash means differentiate with respect to y. Okay. What about d dash square? Differentiate twice. If we differentiate this twice, becomes 0. So this term, all the term becomes 0 because we have square here. That means anyway we get d dash square here. D dash square of y means 0. Okay. Right. So this term also 0. So 1 into y is y. If we differentiate this with respect to y, become 1. We have already 1 d is in the denominator. D represent 1 by d represent integrate with respect to x. We have only one constant term here. So integrating 1 with respect to x become x. Right? Again integrate this with respect to x twice. Okay, if we integrate this with respect to y, we get x squared by 2. Okay, if we integrate y twice, we get x squared by 2. Similarly, if we integrate this with respect to x, become x squared by 2 x cubed by 6, that is x cubed by 2. Okay, right. Now particular integral 3, right? We have e power 3x plus 4y by d square minus d dash minus 2d dash square. Okay, so what is the coefficient of x here? 3. Put d equal to 3 here. What is the coefficient of y? 4. Put d dash equal to 4. So we get 1 by 9 minus 2 minus 32 e power 3x plus 4. After simplification, we get e power 3x plus 4y by 34. Okay, now add all the terms. This is our particular integral. The general solution of z is complementary function plus particular integral. So what is the complementary function here? Is the complementary function. Okay, put here and put all the terms here, hence the solution. Right? Now next problem. So d square minus d dash minus 30 d dash square into z equal to xy plus e power 6x plus y. So here also the auxiliary equation is by finding put d equal to m, d dash equal to 1. We get m square minus m minus 30 equal to 0. If we factorize this, we get m equal to 6 and m equal to minus 5. Therefore, the complementary function is, we have two different roots, therefore f1, f2. So we have 6 here, y plus 6x. We have minus 5 here, therefore y minus 5x. Okay, right here we have two terms here. So we have two particular integrals. One is pi1, pi2. pi1 is xy by d square minus d dash minus 30 d dash square. pi2 is e power 6x plus y divided by d square minus d dash minus 30 d dash square. Okay, so first we are going to find pi1. Okay, that is 1 by d square minus d dash 30 d dash square x. As usual, take d square as common term here. Right, this become like this. Okay, now arrange in powers. Okay, that means if it is in the denominator, it is power 1. If you bring this to numerator, become minus 1. Now apply binomial formula, expand the series. Okay, so now we have complete operators. This is xy, function is xy, order of degree of x is also 1, degree of y is also 1. So if we differentiate this with respect to twice, becomes 0. So 1. So only one differentiation is enough. So up to d dash by d dash d is enough. So leave this all the terms. We get 1 by d square xy plus x by d. Right now, that means d dash means differentiate with respect to y. If differentiate this with respect to y, become x. So x by d. Okay, x by d. Now integrating this with respect to x become x square by 2. So already we have 1 by d square. That means integrate twice. So if we did this, we get this term x cube y plus 6 by 6 plus x power 4 by 24. Now particular integral 2, right? This is very simple, right? Put d equal to 6 and d dash equal to 1. So we put like this, we get 0 in the denominator, right? To avoid this, differentiate this with respect to d. So we put 2d minus d dash and multiply it by x, right? Now put x equal to 6 and d equal to 6 and d dash equal to 1. So we have x into e power 6y plus y by 11. So therefore the particular integral is x cube y by 6 plus x power 4 by 24 plus x into e power x plus y by 11. Therefore the general solution is complementary function plus particular integral. So the solution is f1 y plus 6x plus f2 y minus 5x plus write the particular integral x cube y by 6 x power 4 by 24 plus x e power 6x plus y by 11. Okay, that's all.